Here we're going to visualize how to conduct Hello World in C. Going back to the reading, I want to remind you of this metaphor that we're using of the declarative pathway in our brains as a metaphor for how computers work. And the reason why is because computers, as we discussed in lecture 1, are actually a representation of the mechanization of thought. So therefore, there are three types of ways in which people generally remember things, and there are three types of ways in which computers remember things. And we're starting to touch in how computers remember things when we write Hello World. So recall that we talked about this idea of the neocortex as the long-term memory and the hippocampus as the short-term memory. So in the short-term memory is where we put tasks as well as short-term items that we're going to remember. The hippocampus, it's very short-term, doesn't remember things very long, and we don't really need to remember what we're going to print to the screen for very long. We just print it to the screen and we're done. So here's what we're going to do. First, we are going to indicate how it is we're going to use the functions in C code. Remember that we have #include stdio.h, which stands for standard input.header file. And so here's how we're going to do this. We're going to say touch hello.c. That creates a hello.c file that is empty. And then we're going to do vim hello.c, and we see that there's nothing there. Since we're starting to use vim, I'm going to talk through the basic steps so that way you understand what I'm doing on the keyboard and you can replicate it on your own if you wish. When I type I, notice how on the bottom left it says insert. That means this allows me to be able to insert code. If you don't type the I before you do that, it will not let you insert code through vim. So now let's do #include standardIO.h, and notice how it changes color. In this particular version of vim, it uses purple to include a library, and then it actually puts the library name in red. So now I press enter, and recall that we want to have an input and an output. At this stage, we know that the main is the main function. The input we currently have is void. We're not having any inputs, and the output is going to be int. Also, we learned that C is a base procedural language. So we put in our braces, and then we want to occasionally make sure we're saving. So notice how I'm going to press escape. I'm going to hold shift and press colon, and notice in the bottom it has a green cursor. I'm going to do W exclamation point to indicate that I want to write to the operating system. Now I have saved the current version of hello.c. So now notice how I can't insert anything. I haven't pressed I. Once I press escape, that overrides the I. So I type I again and notice how insert is back. We are going to tab regularly because this allows us in C and then in C++ to be able to keep track of clean code. It's going to make it easier for us to be able to read. Remember that return 0 is the end. So if we look at the correlation here, this return 0 correlates to this integer. It's the output. It indicates to the operating system that we have successfully completed the program. Then in our hello world.c, we also need to print the result. Recall that we use the function fprintf to be able to print to a file. We use the keyword standard out to indicate that there's a reserved location in the operating system where this terminal in Unix reads the characters from this specific output. And so what we're going to say is hello, world, and then /n, as we learned with ASCII, indicates that we are going to have a new line. And at the end, we want to close the bracket and then close the parentheses and then put a semicolon to indicate that that specific task is done. So here's our conduction. We have indicated that we want to do a task. We don't need anything on our input, which is why we have void. Then we are going to print a set of these 8-bit signed integer characters, HELLO, comma, space, WRLD, new line, to a location in memory that's represented using standard out, std out. And we tell this through fprintf. And the reason we know fprintf works is because that is a function that is stored in our standard input output header library. So this is how we have conducted a basic program. Now that we're done, we're going to press escape and we're going to do colon, shift, colon, that's how we do it. You hold the shift and then press the colon, and that's how it works. WQ exclamation point. That means write all the changes that I've made, and then we're going to quit them. So I quit, and now we're going to learn compilation again. GCC is the C compiler we're going to use in this system. Wall is the compiler flags that we've used for all warnings. And then we're going to do hello-c. That takes the C code and checks for errors. We do -o, which is how we're going to link it to an executable. And then we're going to name our executable hello. So it works. And if I do ./hello, it should print hello world. So now we have successfully performed these tasks that we indicated in our conduction in hello.c. We do ls, we see that we have hello.c. It's a very large file. How do we know this? ls space -l, and we see that 8,400 bytes for hello is substantially larger than the 88 bytes for hello.c. So in order to respect the computer that we're using, we use rm for remove, and we type hello and press enter. We do ls-l again, and we see that hello is gone. So now we've saved a good amount of memory in the system. Press clear, and now we're done.